Okay, your first thing is to write down the objective. Students will solve simple linear equations over the rational numbers. And then this is example 1, finding solutions of linear equations. Write that down. And write down the directions. So we are going to list several solutions of 2x plus y equals 10. So in other words, we're going to give values to x. We're just going to make them up. We can make x whatever we want. So let's make x 0. We'll make x 1. We'll make x 4. And let's make x 5. So let's make x 0. That means 2 times 0 plus y equals 10. So then what's y going to be? So this is 0 plus y equals 10. What do I have to add to 0 to get 10? So 0 plus y equals 10 because 2 times 0 is 0. So now what is y going to equal? What do I add to 0 to get 10? I add 10, so y has to be 10 in that case. Now x, what about when x is 1? So 2 times 1 plus y equals 10. What's 2 times 1? 2. 2 plus y equals 10. What number do I add to 2 to get 10? I add 8. So I know y has to equal 8 because 2 plus 8 is 10. What about when x is 4? 2 times 4 plus y equals 10. What's 2 times 4? 8. 8 plus y equals 10. What do I add to 8 to get 10? I add 2. 8 plus 2 is 10. So y has to be a 2. Y has to be 2. And now let's replace the x with 5. 2 times 5 plus y equals 10. 2 times 5 is 10. 10 plus y is 10. Well, how much do I have to add to 10 to get 10? 0. Nothing. Okay? So you needed to write all of that with me. And now here, organize your results in a table. So now I'm going to make an input-output table. So my input is going to be x. My output is going to be y. Okay. So the first number I made x was 0. Right here, x is 0. And when x was 0, what was y? Y was 10. So y is 10. What's the next number I made x? 1. So when x was 1, what was y? Y was 8. What was the next number I made x? 4. When x was 4, y was 2. And the last number, x was 5. When x was 5, y was 0. So now I've organized my results in a table. Okay? So make sure you draw the table as well. Example 2. Writing an equation in function form. So solve for y in the equation. I want you to write 2x plus y equals 10. So when you write it in function form, that means the x is the input and the y is the output. If the y is going to be the output, then I want y by itself on one side of the equal sign. Okay? So now we're solving for y. All right? And I'm not going to get a number because when you have two variables, it's not enough clues to figure that out. Figure out what it is. There are many solutions. Okay? All we want is this to say y equals. Okay? So our main goal, what's our main goal? To isolate y. We want y by itself. Well, what's with y? Right now we have y, we're adding 2x to y. We need to get rid of that. So we're going to subtract 2x from one side and subtract 2x from the other side. 2x minus 2x is nothing, so now this is gone. So now I have the y by itself on this side. Y equals 10 minus 2x. Or I could also write it as y equals negative 2x plus 10, right? So if I switch this 2x, remember this minus means that the 2x is negative. So that's why this is negative 2x. And this 10 doesn't have a minus next to it, so that means it's positive. So that's a plus, positive 10. So you can write it either way. You can either write it as y is 10 minus 2x, or you can write it as y is negative 2x plus 10. Both of those mean the same exact thing. You're going to get the same answers for both of those. And that is writing an equation in function form. So anytime it tells you to write the equation in function form, it means they want the y by itself. Y equals. That's your main clue that it's function form. Okay, if y is by itself on the equal sign, that's function form. Okay? Example 3, writing a table of values. So when we write a table of values, first, we write it in function form. So we're going to get that y by itself. Then, we're going to use the result to write a table of values like we did in example 1. Then, we're going to describe the pattern in the table of values. Okay? So first things first, let's write this in function form. So right now we have negative, sorry, hold on. I don't like the way this is working. Okay. We have negative 4x plus 2y equals 6. And I want my y by itself. So first let's get rid of this negative 4x. So we're going to add 4x, the opposite of 4x, to both sides. Okay? So here this cancels out. Now I have 2y equals, and I cannot add these because they're unlike terms. The 6 doesn't have an x, but the 4 does. Okay? So, the y is still not by itself. The y is now being multiplied by 2. What's the opposite of multiplication? Division. How much do I divide by to get rid of that 2? I divide by 2. If you do that on one side, you have to do that on the other side. Divide by 2. Okay? So 2 divided by 2 is 1. So 1y is y by itself. 6 divided by 2 is 3. Plus 4 divided by 2 is 2. So y equals 3 plus 2x. Or you could even write y equals 2x plus 3. Or y equals 2x plus 3. Because it doesn't matter what order we add in. Commutative property says we can add in any order. So either one of these are fine. Y equals 3 plus 2x, y equals 2x plus 3. I like the 2x plus 3 one, this one, because in terms of algebra, we always write our variables first and our constant terms last. Okay? So I like that one. Okay? Either way, it doesn't matter, though. As you can see, I have it the other way here, and it doesn't matter. Okay? So now let's choose some values for x. So again, you're writing this, and you're drawing this whole table, so make sure you got all that, all right? Okay. Now let's make up some values for x. Give me some numbers. Let's say 0, that's an easy one, and let's do a pattern this time. 1, 2, 3, 4, and 5. Okay? So let's see what happens when x is 0. So that means y equals 3 plus 2 times 0. We just replace the x with a 0. So that means y equals 3 plus 0. Well, 3 plus 0 is 3. So y equals 3. On the next one, we have 1. So y equals 3 plus 2 times 1. That means y equals 3 plus 2. What's 3 plus 2? 5. Can you see a pattern already? Maybe you know what the next number is going to be. Y equals 3 plus 2 times 2. So y equals 3 plus 4. 3 plus 4 is 7. Y equals 3 plus 2 times 3. 2 times 3 is 6. 6 plus 3 is 9. Now hopefully you see the pattern. 3, 5, 7, 9. What's going to be next? 11, and last, 13. Okay? So now we've organized it in a table. Here's our guided practice. Tell whether the ordered pair is a solution of 2x plus 3y equals 7. And explain. So here's my x, here's my y. In an ordered pair, if 1 is x, that means x equals 1, y equals 2. Okay? So now let's replace, substitute the 1 and 2 in the equation. So here's my equation. So I have 2 times x, x is 1, 2 times 1, plus 3 times y, y is 2. And it says that this equals 7. Let's see if it's right. 2 times 1 is 2, 3 times 2 is 6, equals 7. Is 2 plus 6 7? No. 2 plus 6 is 8, so those are not equal. So your answer here should be no. That ordered pair is not a solution. 1 and 2, this ordered pair, these, they do not work in this equation. Do not work. Okay? How about 2 and 1? Let's see if that works. So if x is 2, y is 1. Let's try it. 2 times x is 2, plus 3 times y is 1, equals 7. 2 times 2 is 4. 3 times 1 is 3. Does that equal 7? Yes. So the answer, yes, this does work. How about 5 and negative 1? So 2 times 5 plus 3 times negative 1 equals 7. 2 times 5 is 10. 3 times negative 1 is negative 3. 10 plus negative 3, or 10 minus 3, that's 7. So the answer is yes. How about 4 and negative 1? 2 times 4 plus 3 times negative 1. 2 times 4 is 8. 3 times negative 1 is negative 3. Does that equal 7? 8 plus 3, negative 3 is 5. Does 5 equal 7? No. So your answer is no. Tell whether the equation is linear and explain your answer. We're actually going to cover this tomorrow, so the video is done now, and we'll start here on a linear equation starting tomorrow. Thank you, and I'll see you guys tomorrow.